Welcome. I think this might be the first time I've gotten applause at the beginning of the speech, so I'll take it. Yes, thank you. Yeah, we'll see. I'll be lucky if I get another one, right? Welcome to Flutter for Makers, guys. I am so excited that all of you are here. I love making things, and my goal for this presentation is to share the joy of making with you, and also to explore the idea that Flutter doesn't really have boundaries. Someone said that to me yesterday, is that you think about like programming, and you think you hit like this boundary of what you can do with a certain framework. Flutter doesn't really have that, and I'm hoping that that's one of the key takeaways that you're going to take from today's presentation. By a show of hands, did any of you see my presentation in New York City at Fluttercon USA? Oh, nobody. Awesome. Fresh crowd, awesome. All right. Well, my name is Matthew. I have been developing in Flutter since 2019, and I have never looked back. I adore Flutter. I love Flutter. I am obsessed with the framework. Everything Flutter related is like my favorite thing ever. My day job, I'm a senior mobile developer at a large national credit union. I am from the United States, and so a credit union is like a bank, but it's actually owned by the people who bank there, which is a really cool concept. But that's not my passion. My passion is that I'm a maker, and I'm an artist, and I just love making cool stuff. So, but most importantly, I'm a guy with a YouTube channel. So everyone go to youtube.com/@makerinator, like and subscribe, to see all my cool stuff. No. But, so what are we going to talk about today? What are the topics that we're going to discuss? Well, number one, I'm going to show some of the cool stuff that I've made because I'm proud of it, and so you have to hear about it. After that, we're going to talk about what does it look like if you want to connect a Flutter app to something like an Arduino. We're going to talk about embedded Flutter using a Raspberry Pi. And then I have a really cool surprise for everyone in this room. And that's going to be at the end of the presentation, so stick around for that. I'm not going to spoil it just yet, but it's very cool. And if we have time at the end, we're going to do some Q&A. And with any luck, I'll get you out of here 5 minutes early so you can be the first people in the line for the lunch. So, because I know what the priorities are. Yep. I thought that was going to get me the second round of applause right there. But all right, speaking of lunch, how many of you have trouble figuring out what you want to have for dinner? How many of you have the argument with your partner that is like, what do you want? And they're like, McDonald's, no. Chipotle, no. Taco Bell, no. I invented a machine that solves dinner dilemmas for you. And I actually have it with me today. It's called the Decisionator. And literally what this thing does is you hit a button and it decides what you're going to have for dinner. It just cycles through the choices. It's like spinning a giant wheel. And then whatever it lands on, that's what you're stuck having for dinner. So this is running on a Raspberry Pi. It is powered by Flutter, the Flame game engine, and Flutter Pi. I will be talking more about each of those momentarily. But just real quick, let me just give you a demo of what that looks like. So there is supposed to be sound. I don't know if the sound just isn't working. Oh, there we go. Yes. Oh, we're having IHOP for dinner, right? It's a silly little invention, but there's also, there's chore mode. So if you're having an argument about what chores you're supposed to do around the house, like dishes or whatever, you can use the Decisionator to decide that. There is date night mode if you can't figure out what to do for a date. There is a streaming service mode if you can't figure out what to watch on TV. It's a silly little invention, but I've had a lot of fun with it. And actually, I got featured on Tom's Hardware for this thing, which is insane. They put an article on their blog, which is way more recognition than this thing deserves, but I'm excited about it. Second thing I want to talk about, this is not really a big topic for today, but this is something that I made. How many of us have an old tablet laying around at home that is basically e-waste at this point, but we don't want to throw it out, right? Well, I was thinking, what could I do to use that tablet in a way that it doesn't end up in a landfill, to give it a second life? And I also coincidentally, around the same time, started painting miniatures for like Dungeons and Dragons and Warhammer and things like that. And I was like, it would be really cool if I had a neat way to display those miniatures. So I created something called Backdrop Box. And basically, it's an app that lets you give each miniature that you paint its own custom background that glows from the back of the box, from the tablet. So, if you have like a Space Marine, you can give it like a really epic space background. And you can just swap it out. And it's a lot of fun. fun, and it's a really cool way to repurpose your old tablets. If you want to make one of these for yourself, I've got instructions up on both Hackaday and my blog on how to print it and customize it for your specific tablet. And the Backdrop Box app is free on all the major app stores, including the Amazon Fire app store, because I think a lot of people probably have old Kindle Fires laying around. So that's Backdrop Box. The next one is a love letter to my childhood. I grew up in the arcades. My mom didn't allow video games in the house, but my dad loved video games. So his bit of I don't know, whatever you want to call it, but he would sneak me into the arcades when my mom didn't know. And I loved it. Like, it's some of my favorite memories of my childhood. I would play air hockey with my dad. And my other thing that I loved was pinball. And so I came up with an idea of what if I took air hockey and pinball, mashed them into the same thing, and then made like a little miniature arcade machine out of it that I could take with me and have people play and have fun. What I came up with was Flip Puck, and I actually have Flip Puck with me today. That's the big glowing pink thing over there. And I'll just give you a quick demo of what that looks like. Essentially, it's like air hockey that you're trying to get the puck into your opponent's goal, but also you've got the flippers. That's how you get the puck off to the other end. And there's those glass bumpers, and if you break a glass bumper, then obviously you can that's another way of scoring points. And the first person to get the puck into their opponent's goal 3 times is the winner. Is it a simple game? Yes. But I have so much fun. Like when my niece and nephew came over, they're like, "You built this? This wasn't a kit?" Mind blown, right? So this is also using the Flame game engine. It's also using FlutterPy. It's also running on a Raspberry Pi. And like I said, I'm going to be talking more about that in a minute. But Flutter Embedded is really impressive in what you can do. And I really love the Flame game engine. And I'm not saying that because, All right, so it is demo time. My first demo is what I call the big blue button. The big blue button is this thing. I call it my big blue button because it's big, it's blue, and it's a button. So let me just give you a quick demo real quick. So step 1 is plugging it into a USB port, and that always fails the first couple times you do it. So let me go ahead and get that in there. Second try, impressive. All right, and I'm going to open up an app that I call Flutter Fortunes, or the Flutter Fortunator. Is there anyone who is brave enough to get their Flutter fortune told by hitting the big blue button? Anyone who wants to come up and just smash? Okay, give a big round of applause, thank you. Hit the button. Follow the path of Riverpod, and you shall find a state of true enlightenment. Give them a big round of applause. Thank you. So I accidentally unplugged it when I picked it up to show you guys, so I'm going to hit the button again so you can see what it's supposed to do. When I hit it, it's supposed to light up like a Christmas tree, so let's do that. Hot reload is your superpower. Use it wisely, for with great speed comes great responsibility to not break everything. Yeah. So these fortunes came from Gemini. There's like 20 different fortunes that it cycles through. So essentially, the reason that I wanted to show this to you is because this demonstrates a whole lot of different things about how you can integrate an Arduino into a Flutter app. So what I'm going to do is I'm just going to hop back over to my presentation, and we will continue from there. From current slide. Excellent. So, you're probably wondering how this works. Well, the way that this works is through the magic of serial communication. You know, breakfast really is the most important meal of the day, and if you don't have a good breakfast, you might have a bad... I'm sorry, that is a terrible joke. My partner told me that I should remove it from the slideshow, and based upon the awkwardness in the room, I totally should have listened to her. No, it works through the magic of serial communication. So you saw me plug in a USB cable. I think everyone knows the S in the USB is serial, universal serial bus. And literally what's happening is on a very high level, I hit the big blue button. It sends literally the word activate from the Arduino via serial to my laptop. The Flutter app is just listening for that word activate to come through. When it sees it, it kicks off the Flutter fortune cycle, which is the music, the dancing dash, and then the fortune that you saw. Once that cycle is done, it sends the word deactivate back through the wire to the Arduino, and that turns off the lights, and that resets everything. So that is a very high level of how that works. Let's take it one step deeper. So this is a schematic of how the big blue button works. It's just a schematic, guys. It's not as intimidating as it looks, I promise. On the left-hand side here, this big yellow square is the Arduino. And you'll see that on pin 5 is where we've got our push button connected. So the push button that you see, SW1, that's literally the big blue button on the top of the box there. And that is then connected to the ground pin. So the Arduino is basically listening for us to hit that button, and that's what kicks everything off. Now on the right-hand side, you're going to see that we have a 12-volt power supply coming in. First question a lot of people ask is, you've got power coming from the Arduino, why do you need a separate power supply? And the answer is, if I tried to power all those LEDs from the Arduino, I'd burn out the Arduino. Like, it just can't push out that much power. So that power is going through this little thing, D1 here, that's the LED. Those are just the LED strips that you saw light up when I hit the button. And then it goes down to Q1. Now Q1 is a transistor. I think most people know what a transistor is, but in case you don't, it's just a switch, just like a light switch, but it's controlled by a voltage. So what happens is when the button is pushed, the Arduino sends a voltage to the transistor, which then says, okay, I guess I turn on now, which then turns on the LEDs. And then when the fortune cycle is complete, it just turns the voltage off of pin A7 there, which then so the transistor sees that and it's like, oh, I guess it's time to turn off. LEDs turn off, the whole thing resets. Now, the one thing that confuses people, and this is a really important point, is R1. Why do I have a random resistor sitting there? Anyone know? It's a pull-down resistor. Yep, okay, one guy in the back knew. It's a pull-down resistor, right? So we're all developers. We are used to working in the world of binary. True, false, on, off, yes, no, 0, 1. The real world does not work like that, guys. The real world is like somewhere in between, right? And so the problem is this transistor is really sensitive. Static electricity will set it off prematurely. Radio waves from the Wi-Fi or your microwave will set it off prematurely. So what this resistor is doing is it's basically, think of it as like a drain. It's just draining all that excess energy that we don't want triggering the transistor off the line. And then when the only voltage it's going to detect is what's coming out of the Arduino to actually turn on the LEDs, right? So that is, I took the time to explain that because if you don't put a pull-down resistor in your stuff, your buttons will trigger off randomly. Like, this is an important concept for you to know if you're doing anything like with electronics. So, enough about the hardware. Let's jump into software. So this is Arduino code. This is just C. Dart is a C-based language, so if you know Arduino, if you know Dart, you already know C. First thing we're doing is defining what the pins are for the buttons. So I'm assigning the button to pin number 2 on the Arduino. The light pin that is turning the LEDs on and off is pin A7. And then I'm just setting up some state. Now you'll notice that I've got fortune reading active there. The idea is I didn't want someone to be able to just smash the button a bunch of times and then potentially crash the app. So once you hit the button, it just locks it out. I think we're used to seeing stuff like that. And then, we set up the serial communication, and I explained what those pins on the Arduino are going to be doing. So the button pin, I'm saying, is an input, and you'll notice the word pull up there. I just explained what a pull down is. So a pull up is the exact opposite of a pull down resistor. And then I set the light pin as an output. From there, essentially, the big thing that you'll see is like I've got that serial.println activate. That's just me sending the word activate across the serial port so that the Flutter app can listen to that. And then the last thing here that's super important is this listen for serial update function, because remember, we're not just sending information to the Flutter app, we're taking information back from the Flutter app as well. And so that's what this listen for serial update is. We're just listening for the word deactivate to come through. When that happens, we take the light pin to low, which means we're turning the LEDs off, and we're resetting everything so that the cycle of the Flutter Fortunator can continue once again. But this isn't an Arduino conference, is it? This is a Flutter conference, and I can see some of you in the back. Show us the Flutter code, we don't care, right? I can see that, right? So if you're going to do any serial communication with Flutter, I've had really good luck with the Flutter libserialport package. This is just a wrapper for the libserialport C library. It works on everything but iOS. Surprise, surprise. We all know that Apple loves open standards, right? And in web, obviously, it doesn't work on web either. But pretty much anything else you can use this for. And you can connect any Flutter app to an Arduino on pretty much any other platform that you can think of using this. It's a super, super easy library to use. I'm going to show you some code here in a second. And I highly recommend if you're going to do anything with this and you don't need to support iOS or web, just use this package. It's going to be your best bet. So this is a RiverPod provider. First thing that we're doing is we need to query our serial ports. So most computers have multiple serial ports. Mine has 7 on it. And the question is like, what USB port am I hooking my Arduino into? Well, the simplest way to figure that out is not to like only ever use one USB port on your computer. It's to just scan and see what all's connected. So my generic AliExpress Arduino Nano clone identifies as FT232R USB UART. Your Arduino branded Arduino that you buy from the Arduino company is probably going to say something different. So the first thing that you need to do when you do something like this is you need to plug in your Arduino, just see how it reports itself, because what you're going to do is you're just going to get all the available ports and then you're going to look for that label, and that's how you know which serial port that you need to use. So once you get that, after that, you just set it up for reading and writing. This is all in the docs. It's nothing particularly revolutionary here. But the important part at the bottom is that you get a stream from your Arduino from the serial port. Now, I'm sure most of you understand how streams work. It's pretty foundational to Flutter. So you're just getting a stream of data coming in from the serial port that you're going to listen to and then take action on. Now, I do have a process incoming data function there. So what is that doing? Well, I'm glad nobody asked. We're going to take a look. So the process incoming data is literally just a buffer. So you have to have a buffer because literally if you're listening to a stream of serial data, you might get the letter A and then the letter CTI and then maybe the letters VATE. And if you don't have the buffer, your Flutter app isn't going to know what to do with that. So to make sure that you're sending consistent output to your Flutter app, you need to create a buffer. So basically what I'm doing here is I'm just collecting all the data that's coming from the serial port until I get a new line character. When I see the new line character, I know that I'm done. And at that point, I'm just going to go ahead and send that data on to the Flutter app. And I do that by throwing it into another stream. So you could use a stream transformer here. There's an argument to definitely use a stream transformer here. I didn't because this is a demo app, and honestly, I'm not reusing this logic anywhere. So like they're putting it into a separate transformer just didn't seem particularly necessary, so I am using 2 streams here. But then I've just got the write string method, and like literally what I'm doing is when I need to send data back, I just put it into port.write, and then whatever you've got there, you can just yeet back to the Arduino, and you are good to go. So that is really cool, but it is digital communication, right? All you saw was a button press. What if in your Flutter app, you want to hook it up to a temperature sensor or a humidity sensor or anything else that is not just a binary 0 or 1. Well, that's where our second demo of the day is going to come in. And I call this one the twisty dial. Now, this one is not nearly as exciting as the first one, but it demonstrates some important stuff. So I'm going to show it off to you here real quick. Let me just open up the knob demo here. So you should see a fairly familiar looking bird there. This was going to be a flame game. I didn't get to it because I got sidetracked. But there's I've got a knob here, and as I twist knob, ooh, ah, ooh, ah. This was going to be Flappy Bird, guys. This was going to be Flappy Bird controlled by a knob. This is some collision detection and some pipes away from being Flappy Bird with a knob interface. Okay, but the important thing here is like this is not binary. Like I have a rotary encoder here, and then the bird literally is going up or down based upon how far I twist. Not a rotary encoder. I'm sorry, a variable transistor. I'm using the wrong word for it. Wow. It's really difficult when you're on this side of the speaker stand. I'm sorry, guys. But yeah, it's potentiometer. That's the word I'm looking for. This is a potentiometer, okay? And so the question is, like, how do I get that data into my Flutter app? So let's go back to the slides, and I'll do a quick demo. And duplicate slideshow. Okay. So a potentiometer has 3 prongs on it. So on the left, you're going to see the same Arduino that we saw before, but you'll see that there's 3 pins. So pin number 1 of the potentiometer is connected to 5 volts on the Arduino. Pin number 3 on the potentiometer is connected to the ground plane of the Arduino, and pin number 2 is connected to pin A2. So what's going to happen is as I twist the knob, it is going to send back a number via serial that is 0 to 1023 inclusive. And based on that, I can tell how high or low the potentiometer is twisted. So the serial communication port is exactly the same as the big blue button, so I'm not going to rehash that. But what I do want to point out is that we're using something called a moving average filter here. Why am I doing that? Well, remember like 2 minutes ago when I said the real world was like never actually fully accurate? This potentiometer will sometimes say, I'm at 5, I'm at 6, no, I'm at 4, I'm at 5, all in like the fraction of like a second, right? It's going to constantly be sending back numbers that are within like a small range, but are not 100% accurate. Now, there's 2 ways of solving this. The first one is I could have been lazy and threw a capacitor into this thing, and that would have helped smooth things out. The second one, though, is just using a moving average filter. So the way a moving average filter works is you're just taking 10 readings from the potentiometer, you're then taking the average of those 10 readings, and that average is what you send on to your Flutter app. Because the idea is that you're going to be within an approximate range. So the average should be really close to consistent, even if the actual numbers you're getting from the potentiometer are not. So if I didn't have this moving average filter, the bird would have been like, you know, it would have just been having a seizure on the screen. But using the filter, what that does is it smooths it out so that the move is consistent. Now, the downside to this is that if you have something like Flappy Bird that is very responsive, the moving average filter does introduce a little bit of a delay because you're collecting up multiple samples. So that is a trade-off, but it was a worthwhile one in my book for the demo. All right, that is a lot of conversation about Arduino. I want to talk to you about Flutter and Raspberry Pi. I love embedded Flutter. And so that is what the Decisionator and Flutpuck are both using. They are running Flutter on a Raspberry Pi. And the first thing that I want to point out is that the entire Flutter community owes a huge debt to Ardera on GitHub, or I believe his name is Hannes. I know that Flutter Industrial, or Industrial Flutter, is a sponsor. Hannes used to be with Industrial Flutter. And so what Hannes has done is he's written a not a package, but he's got a project called FlutterPi. FlutterPi is a Linux embedder for Flutter, and it will work on pretty much any Linux system, so even if you're not using a Raspberry Pi, it'll work. But what makes it special is you don't have to have like a windowing system for your Flutter app to work. So you don't need GNOME, you don't need KDE, you don't need any like X desktop system on Linux. All you need is your command line, and then your Flutter app will run. So why is this important? Well, we're working in a resource-constrained environment. And if you have like a windowing system, that's using up a ton of RAM, video memory, all that good stuff. This, you get all that back that you can use with your Flutter app. So you can get some really impressive performance by just only using what you need, which is the Flutter command line. So I really recommend if you're going to do anything Flutter embedded and you want to experiment with doing things on a Raspberry Pi, Flutter Pi needs to be your first stop. You need to check that out. One caveat is if you're going to do this, your development experience is going to be dramatically better if you do it on a Linux system. Just because it's porting it from one thing to another. You're going to save yourself a lot of headaches if you just do your development in Linux in the first place. So then the question is, all right, so Raspberry Pi, but you notice I've got buttons. On both FlipPuck and the Decisionator, I've got buttons, and I'm not using an Arduino on these. How am I getting those button inputs? And the answer is the Raspberry Pi GPIO. So every Raspberry Pi has a series of pins, kind of like an Arduino. They all do different things, and this is like the pinout of what the Raspberry Pi pins do. But there is another package by Ardera called Flutter GPIO-D. And this is the package that I generally just always use when I need to access Raspberry Pi GPIO. It makes it really simple, and you can pretty much access any of the GPIO pins. You don't need to use an Arduino. You don't need to use serial communication. It just works. Now, the one caveat that I want to point out here is that on the Raspberry Pi, your GPIO is digital only, which means you can do button presses and you can turn things on and off. But if you want to do things like the twisty dial demo that I just did, or if you want to do like a temperature sensor or something, Raspberry Pi GPIO cannot do any type of analog input or output. So if you're going to do that, at that point, you now need to hook an Arduino into your Raspberry Pi, and you're back to serial communication at that point. So here is some like general code for how to access a Raspberry Pi GPIO. This is Decisionator code, which is why you're going to see like a mode button and a spin button. The first thing I'm going to do is I'm going to find the GPIO chip. Kind of like we were trying to find the right serial port earlier, we need to find the right chip to communicate with. So that first one, pin control BCM2711, that is the Pi 4's GPIO chip. Pin control BCM2835, that is the Pi 3's. I don't know what it is for the Pi 5 or the Pi 0, but your first stop is figure out what the chip name is, because that's what you're going to use to communicate with your GPIO. After that, you just define your lines, very much like we did with the Arduino. So I've got a spin button pin that I've identified in like my configuration constants, and a mode button pin that I've identified in my configuration constants. And I'm running a method called setupButton. So all that's doing is it's saying, okay, I'm going to request an input from this specific pin on the Raspberry Pi, and then you've just got a listener that is going to listen for the button to be pressed, and then once it happens, I've got an on-push function there. You can imagine that that is whatever code that you want to happen when the button is pushed on your Raspberry Pi. So like I said earlier, any Linux distribution is going to work for you. There's two that I recommend if you're getting started, and it depends on the approach that you want to take. The first one is Raspberry Pi OS Lite. Now what makes this nice is you have a fully functioning Linux distribution out of the box. It's just going to do what you need it to do. The downside to this is that your performance isn't going to be as good because a whole bunch of stuff is going to be turned on that you don't need. So to optimize your performance, you need to go in and be like, okay, do I need Bluetooth communication? No? All right, then I'm just going to turn off Bluetooth. And so you need to go through all those things. So you don't get, I think, as optimized as a solution at the end, but you start with something that works. And if you're just starting, there's a lot to be said about having something that just works and then optimizing from there. The alternative is something called BuildRoot. And I love BuildRoot, but it is a little bit more advanced. So BuildRoots, you start with just like a very basic Linux kernel that does nothing. And then you add all the stuff piece by piece that you need. So in the other one, you're taking away until you have everything that you just need. In this, you're adding, and then you don't add anything else once you have the stuff that you need. The cool thing about BuildRoot is that it supports FlutterPi out of the box. So if you are in the BuildRoot configurator, you can check and say that I want this to be able to run FlutterPi apps. It will then install all the dependencies on that, and it makes it very simple unless you're doing something crazy like I do with custom sound and stuff like that. But that's beyond the scope of this talk. So BuildRoot is cool. And if you want something that's a little bit more performant and you're okay with spending some time on your configuration, it's definitely worth taking a look at. All right, so this is the last portion, guys. Stick with me. This is going to be amazing. This is where everybody gets to participate. In the keynote this morning, I think it was really interesting that the conversation was like, what about the puzzle pieces that are missing for Flutter? And it's so crazy because I was thinking, what are the puzzle pieces that are missing for Flutter before I even came to this conference? And I decided to address what I consider to be the biggest problem in the Flutter community today, which is the lack of plush dashes. Why is it so hard to find dash? Like, it's almost impossible to get your hands on one. Like, I got one only because I was super, super lucky. And I'm like, if we want Flutter to succeed, if we want Flutter to 2x, we have got to address the great dash shortage. So I promise that there's some tech with this, guys. Hold on. But my partner decided to help by... I'm a software developer. She is a software developer. She is really involved in the knit and crochet community. And so my partner created a dash crochet pattern. So we have open sourced this pattern. It is on my GitHub. So if you want to make your own stuffed dash, you can go there and download the pattern and make your own stuffed dash. Her contact information is there. If you've got questions, she's more than happy to help you if you get stuck or need assistance. But I'm like, how can I take this to the next level? Because I'm sure there's a few people in this room that don't want to learn how to crochet. I could be wrong about that, but I'm thinking that there might be 1 or 2 people in the room. So I decided to take it to the next level, and I had my partner create 12 different dashes. And in the bottom of every dash, I have put a Bluetooth beacon that is broadcasting a signal. And if you guys all want to download the Flockinator app right now, I've hidden 12 of them around the conference center. So what you're going to do is you're going to install the Flockinator app, and I'll give you a hint. There's actually 2 hidden in this room. You're going to install the Flockinator app, and then you're going to see some statuses. The first one is she's right under your beak, which means you are right on top of a dash. It's probably within like a foot or 2 of you. The chirping is getting louder, means that you're near a dash, but you're not like right on top of it. If you hear a distant flutter, it means that you're within range of a dash, but the signal is pretty weak. And then if you see something that says the skies are clear, that means that there's no dash available. So everyone download the Flockinator app. When you find a dash, you're going to see that each dash has a tag attached to it. There's a QR code on the back of the dash, and if you scan that with the app, this is connected to a Firebase. It'll deactivate the beacon so that people aren't following you around looking for your dash all day. And you can either keep that dash as your own and keep it forever, or you can move that dash to a new hiding place and scan the code to reactivate her so that someone else can find her. It's entirely up to you. So I'm going to open it up to questions here in a second, but these are all the places to find me. I don't do a lot of social media, but when I do, it's usually Blue Sky or LinkedIn. The GitHub is there. All the code for everything that I talked about today is in that GitHub. And of course, YouTube, guys. That's where I post all my coolest stuff. Like and subscribe. And the QR code for Flockinator is right there. Download it, install it, and happy hunting. Thank you very much.